Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC Civil Service Mains Exam 2022. So in this video, I will discuss 2022 question paper Physics Optional Paper 1. So let's start. So now in this video I will discuss question which question ask. So wait and watch. So first section is here. An electron is moving under the influence of a point nucleus of a atom number Z, so that the orbit of electron is an ellipse. And question number B is here. So that the means of kinetic and potential energy of a non-dissipative simple harmonic vibrating system are equals. And question number C, of an observer on a railway platform observe that as a train passes through the station at 108 km/h, the frequency of the whistle appears to the drop by 3015 Hz. Find the frequency of the whistle's velocity of sound is air is 380 meter per second. And question number D is here per second, meter per second. And question number D is here. So that the very small velocity, the equation of kinetic energy K is equal to delta mc square becomes K is equal to 1 by 2 m0 v square, where notation of their usual meanings. So this is the question D. And question number E is here. A phase retraction plate of quarters has thickness 0.1436 mm. For what wavelength in the visible region will it act as quarter wave plates? Keep that the mu0, mu0 is equal to 1.5443 and mu e is equal to 1.5533. And question number 2 here you see. So this is question number 2 here. Consider the two frame of reference S and S dash having common origin O. The frame S dash is rotating with the respect of the fixed frame with a uniform omega equals to 3a x radiation second, and a projectile of unit mass as position vector r is equal to 7ax plus 4ay m is moving with v is equal to 14ay meter per second. Calculate the rotating frame s dash following the force on the projectile: Euler forces, Coriolis forces, centrifugal forces. And question number B is here. So question number B here. A particle P of mass m collide with another particle Q of mass mq at rest. The particle P and Q are travel at angle theta and phi respectively with the respect to the inertial directions of P. Type the expression for the maximum value of theta. And question number C is here. Obtain the system matrix for a thick lens and drive the thin lens formula. And question number 3a. A homogeneous right triangle pyramid with a base side A and height 3a by 2 is so below. Obtain the momentum of inertia tensor of the pyramids. So question number A is here. So this is the diagrams. So figure out next. Question number B is here. Newton's rings are observed between a spherical surface of radius of curvature 100 centimeters and a plain glass plate. The diameter of fourth and fifth 15th bright rings are 0.314 centimeter and 0.574 centimeter respectively. Calculate the diameter of 24th and 30th bridge rings, and also the wavelength of light is used. And question number C is here. In a helium neon ledger, what is the function of helium gases? Explain the answer with help energy level diagram for helium neon ledger. So this is brief. This is helium neon ledger and ruby ledger. There are two. Question number 4 is here. Consider the diagrams below with a waterfall rate Q. Derive the expression for Q in the term of the difference in a manometer height H and the cross section area A1 and A2. So this is, you see, this A1, A2, Q, Q. So this is the diagrams. And question number B is here. Discuss the phenomena of Fraunhofer diffraction at a single slit and show that the intensities of successive maximum are nearly in the ratio. So this is, you see this. In question number C, the two spaceships approach each other, both moving with the same speed as measured by the stationary observer on the Earth. Their relative speed of 0.7 c. Determine the velocity of each spaceship are measured by the stationary observer on the Earth. And section B is here. So you see. So assume that the Earth atmosphere a pure nitrogen in a thermodynamics equilibrium at a temperature of 300 Kelvin. Calculate the height of above sea level at which the intensity of atmosphere is 1/2 its sea level value. So molecular weight of N2 is 218 gram moles. So question 5A and B is here. You see, a body of a constant heat capacity Cp and a temperature Ti is put into contact with a receiver at temperature Tf. Equilibrium between the body and the receiver is established as constant pressure. Determine the total entropy change and prove that it's positive for either sign of Tf and Ti upon Tf. Consider that Tf minus Ti upon Tf is less than 1. And question number C is here. Consider 2-point particle of charge q, each separated by the distance d and traveling at a non-relative velocity v. If the line joining two charge is perpendicular to v, then write the expression for the magnetic force between the two particles and illustrate the direction of the force on each particles. And question number is here. A cell of internal resistance 1 ohm, 1.5 volt E electromagnetic force, and other cells of inertial resistance 2 ohm and 2 volt electromagnetic force are connected in a parallel across the end of an external resistance of 5 ohm. Find the current in each branch of the circuits. And question number is here. Consider the RLC circuit shown here. Calculate the Q factor of the circuit. Does the circuit have a resonant frequency? Justify your answers. So justify your answers. In question number 6, write down the Maxwell equation. Write down Maxwell's equation is a non-conducting medium with constant permeability and susceptibility rho equal to j equal to 0, so that vector E and B each stratify the wave equation and find the expression for the wave velocity. Write down the plane wave solution for vector E and vector B, so that E and B are related. So this is conducting medium Maxwell equation alpha betas. And question number B is here. One mole gas of a van der Waals equation of a state if its molar internal energy is given by U equal to Ct minus A by V, in which V is the molar volumes, A is one of the constant in the equation of the state, and C is a constant. Calculate the molar heat capacity Cv and Cp. And question number 2 is here. A compressor designed to compress air is used to instead compress helium. It is found that the compressors overheat. Explain the effect, assuming that the compressions and approximately adiabatic and the starting pressure is the same for both of the gases. So this is air, helium. So question number C is here. A gas is interacting atoms has an equations of a state and heat capacity at constant value given by the expressions. So PTV AT 1 by 2 plus BTQ plus CV minus 2 and CVT at dt 1 by 2 et square by v plus ft 1 by 2. So where a through f is constant which are independent of t and v, find the differentials of an internal energy du dv in the term of dt and dv. And question number 7a. A metal guitar string with the length of 17 cm vibrates at its fundamental frequency of 246.94 Hz in a uniform magnetic field of 10 T, oriented perpendicular to the planes of vibrations of the string. Assume a sinusoidal from the amplitude of the vibrational mode and a maximum displacement of 3 millimeters at the center of the string. What the maximum EMF generated across length of the guitar string, and at what point in the time in the string motions does occur? What would be the EMF electromagnetic force is the same guitar string vibrate of it is second harmonic frequency verify. So this is a string related questions. And question number B is a thermally insulated cylinder closed at both ends is filtered with the frictionless heat conducting pistons which divide the cylindricals into two parts. Initially, the pistons is clamped into the center with 1 liter of air at 200 kelvins and 2 atm pressure on one side and 1 liters of the air of 300 kelvins and 1 atm pressure on other side. The pistons are released and the system reaches the equilibrium in the pressures and temperature with the pistons at a new positions. Compute the final pressure and temperatures. And question number 6 here. This is the numerical boss. A current sheet having K is equal to 9.0 AY, AM per minus 1 is located at Z equal to 0. The interference is between the origin A1, Z is less than 0, UR1 is equal to 4, and region 2, Z is greater than 0, UR2 is equal to 0, given that the H2 is equal to 14.5 AX and 8.0 AZ, ampere per meter, A per minus 1. Find the H1 and B1. So question number 8 is there. In a partially conducting medium, ER is equal to 18.5, mu R is equal to 800, and the sigma is equal to 1 S m per minus 1. Find alpha, beta, and zeta, and the velocity u for the frequency of 10 to the power 9 Hz. Determine HZT given EZT is equal to 50 E minus az alpha z, sorry, cos omega t minus beta alpha az is equal to ay v power minus 1. And question number b is here. What do you understand by the negative temperature? Write down the explain the various restrictions on a system for the concept of negative temperature to the beginning pools. And question number c is the last. Starting from the Laplace equation in a cylindrical polar coordinate systems and using the method of separation of the variables obtain the differential equation for the solution of r theta z component of the potential. So this is, and these are the two types, cylindricals and spirals. So this is proved as cylindricals. So that is all related to this discussion for today. And I hope this video help for your coming examinations, and I would like wish all students good of luck. Thank you for